Hey everyone, my name is Jose and 2023 is already here. Throughout 2022, it's nice to see how far smartphone cameras have improved. For example, the processing of the Google Pixel 7 Pro is really nice, the physical aperture mechanism on the Huawei Mate 50, and the IMX, the 989 1-inch type sensor on the Vivo X90 Pro Plus and the Xiaomi 12s Ultra. It's been a really good year. And I want to make this video as part of a half follow-up to this video about how our smartphones supposed to be real cameras by 2024. So you should probably go check out that video as well. Instead of actually following up on that video, I kind of want to take this time to talk about assistive camera sensors and explain them more in detail as I did in that previous video. The thing is, while the IMX 989 is doing wonders for smartphones, it's only one part of the equation to having a good camera system on a phone. I mean, you have photo processing, of course, and other camera sensors like ultrawide and telephoto, but let's focus on that photo processing. Even with that IMX 989, you still need really good photo processing if you want your phone's camera to feel really premium and really rich as if it was a real camera. And while I already explained the software side to camera processing multiple times, for example, in that previous video, I still want to talk about hardware because it's an option that manufacturers can take. So in this video, I will be explaining 7 different assistive camera sensors that, if utilized correctly, they can provide meaningful information to the main sensor, telephoto, and ultrawide, and basically you get better camera results. And first up, we have everyone's favorite camera sensor, a 2 megapixel depth sensor. Now yes, a 2 megapixel sensor of any kind is more filler than it is actually practical, but as I will explain right now, that doesn't mean that all depth sensors are bad, because they're not all bad. So depth sensors are usually 2 or 5 megapixels and are really prominent on really cheap phones like my Poco X3 Pro, which is a $250 phone. But what does a depth sensor even do? It's used for 2 things. It's used for applying a more realistic cutout to portrait bokeh shots, and it can also help boost dynamic range of any photo. So a depth sensor is a monochrome sensor, usually with a fixed focus, and they're really tiny, and I'll provide some real sample shots from a real depth sensor, like this was taken on my Poco X3 Pro. And keep in mind, these shots weren't actually shot with the monochrome filter in the main camera app. No, that was actually taken on the 2 megapixel depth sensor. That's actually what depth sensors actually look like. So when you put a cheap monochrome sensor on any phone, the phone can use 2 camera views because it has the main camera and the depth sensor to estimate depth, and this process is called parallax. So that monochrome sensor becomes a depth sensor just because it's offset from the main sensor, and that's how it tries to apply more realistic bokeh cutouts. If you're familiar on how to take an HDR shot manually, you would know that you take shots at multiple exposures, and one of those shots has to be monochrome so that you can recover details when you stitch all of the photos back together. It's the same thing for 2 megapixel depth sensors. The phone has the ability to take a single frame from the depth sensor and apply it to all the other frames captured by the main sensor, but that's only if the manufacturer actually coded this. It doesn't happen all the time. At least I don't think it happens all the time, but it makes sense for it to happen though. Depth sensors have been around since the Huawei P9 in 2016, and that was used to boost the dynamic range of photos, especially in low light, because these monochrome sensors are more sensitive to low light because it's not taking any color. However, those depth sensors on the Huawei P9 and all the phones after that, they weren't called depth sensors, they were called monochrome sensors, but I don't really think that they use parallax for portraits, but I could be wrong about that. And the best part about these monochrome sensors back in the day is that if you practically asked anyone, they wouldn't say that, oh, this is a cheap sensor or anything, because no, these sensors were usually about 16 megapixels or around that range, and they did have a legitimate purpose of boosting dynamic range. But if you fast forward to today, any phone that kind of has a monochrome sensor is used for depth sensing, but they're used for filler purposes because it's a really cheap camera and doesn't really do a whole lot. I mean, you could look at the OnePlus 8T. That had a 2 megapixel monochrome sensor that was used for depth mapping and the whole HDR thing, but it was still 2 megapixels and you put it on the flagship device, so it was still a filler camera. However, if you look at the Huawei P50 Pro, they brought back the depth sensor, but it was 40 megapixels and it was a lot bigger than the standard sizes for 2 megapixel depth sensors. And that 40 megapixel monochrome sensor on the P50 Pro was used for HDR purposes, enhancing the clarity of photos, low light performance, all that. So that implementation of that 40 megapixel monochrome sensor was actually good. It was actually meaningful and it wasn't necessarily filler. And I'm pretty sure that 40 megapixel monochrome sensor was used for depth sensing because parallax still works because the cameras are just offset. But my overall thoughts on depth sensors is that if you have a 2 megapixel, 5 megapixel depth sensor, it's more filler than it is actually meaningful. But if you do it right, like what Huawei did with the P50 Pro by putting a 40 megapixel depth sensor, monochrome sensor, on the phone, then yeah, we can bring back depth sensors on phones onto flagship devices if you do it right and you don't really cheap out on it, because it does boost dynamic range and help with low light performance. Onto the next sensor, laser autofocus. This sensor is used on more premium phones than it is used on cheaper phones, but what it does is it makes autofocus more reliable. It essentially shoots out a single laser and it calculates how long does it take for the laser to bounce back. And by doing this, it kind of helps cameras, especially in low light, to autofocus faster and more reliably, because if you don't have laser autofocus, then the main sensor has to use PDAF and whatever other technologies to focus, which can be really hard because there's not enough light for the sensors to do this. So by having laser autofocus, you speed up the process a lot faster and a lot more reliably. And yeah, onto the next sensor. That one was really fast, but we'll come back to it later. So the next one is time of flight. And it's one of my favorite assistive camera sensors, if I might add. Time of flight works by having an infrared emitter shoot out multiple infrared beams, and then the camera calculates how long does it take for the beams to bounce back. And that's used to create really nice bokeh cutouts because you're shooting out multiple beams, and that's basically depth mapping foreground and background surfaces. And that's basically seen with my Huawei P30 Pro. It's also really good for AR applications because you're still depth mapping surfaces and you can basically interact with the world in a realistic way. Lastly, time of flight can be used for autofocus because the time of flight sensor can know how far are you from your subject and give that information to the main sensor so that it can properly focus. And I think time of flight is just way better than laser autofocus, but we'll talk about that later. However, I should note that if you ever hear time of flight and relate that to a smartphone, what is really being said is direct time of flight, or DTOF. Because time of flight can also be indirect, also called ITOF. And basically what that does is it just does the same thing as laser autofocus, and it can't actually depth map like DTOF. So DTOF is way better than ITOF. Oh my God. And next up is a derivative of time of flight, which is LiDAR. LiDAR basically works the same way by shooting out multiple lasers and calculating the time it takes to bounce back, but it has some strengths and weaknesses over DTOF. LiDAR has the possibility of using different lasers running on a different wavelength than regular DTOF, which can increase the accuracy of depth mapping, but at the same time, like regular light sources can easily disrupt the infrared lasers, so it kind of weighs back as well. Just on the surface, it looks like LiDAR is better than DTOF because it's more accurate, but at the same time, DTOF is better in low light scenarios because it has a longer wavelength. So it's kind of the same in some ways. And the next sensor is another filler sensor, just like a 2 megapixel depth sensor, except I hate this sensor a lot more, and you're going to find out right now why. And it's a color temperature sensor. So phones already have color temperature sensors on them. Just look at the iPhones. iPhones have color temperatures on them to use the True Tone display to automatically adjust white balance depending if you're in indoor or outdoor lighting. And if I'm not completely mistaken, I think ambient light sensors, which is used to basically automatically adjust screen brightness based off of if you're inside or outside, I think they could be bundled as color temperature sensors at the same time. But even if that's right or what's wrong, basically color temperature sensors are on the front side of your phone next to your selfie camera, and it's basically embedded in the bezels. However, the reason I'm even talking about color temperature sensors at all is because of the stunt Huawei did when they released the Huawei Mate 50 phones. So these Huawei phones have 4 camera sensors: a main, an ultrawide, a telephoto, and suspiciously, this color temperature sensor. Like, phones already have this sensor. It's on the front side of the phone, next to the selfie camera, next to the proximity sensor, next to all the other sensors on the front side of the phone. However, Huawei put it on the camera bump next to all the other camera sensors. And basically, the reason they did that is because they wanted to make the camera bump look symmetrical by having a sort of quad camera array kind of look to it. And by doing that, by putting the color temperature sensor on the camera bump, it makes me or any other consumer think that, oh, the Huawei Mate 50 phones have a quad camera setup, when in actuality, they kind of don't. And this color temperature sensor is on the camera bump on the Huawei Mate 50e, the Base 50, the Pro model, and the $1,800 Porsche RS model. And I think it is absolutely horrendous what Huawei has done by putting this color temperature sensor on the camera bump to make it look like a kind of fake camera setup, quad camera setup, and let alone for the $1,800 RS version. Like, you're really gonna put a filler camera on a really premium phone? Like, that's insane. And guess what? It's not only Huawei doing this, the newly released Vivo X90 and X90 Pro also have a color temperature sensor placed right next to the other 3 cameras. So that also looks like it has a quad camera setup, except that color temperature sensor isn't a real camera and it's a filler sensor. Even though this documentation or presentation says DTOF on the page, why I think it's a color temperature sensor is because, one, I don't see an infrared emitter on the back of the phone, and 2, that sensor is too small to be a good time-of-flight camera receiver. So, and when you look at the specs page, it says rear chromatographic sensor, which is basically just jargon for a color temperature sensor. I mean, I know I'm not explaining this a whole lot because I already explained it in my other video, my commentary video on the X90 phone. So if you want to go see me explain it even more in detail, then go ahead. I also explained color temperature sensors on the Huawei Mate 50 release. So yeah, that's it for color temperature sensors because they get me super mad. So the bottom line is, by moving the color temperature sensor from about here to the back of the phone, putting it on the camera bump, it has the same role and purpose of a 2 megapixel depth sensor because it makes the camera bump look more symmetrical and stylish. So yeah, this color temperature sensor literally is the new 2 megapixel depth sensor. It's just filler. It's really basic. You didn't need to move it from here to here, but they did it. So yeah. Yeah, let's move on to the next sensor because I kid you not, color temperature sensors make me mad. So I'm happy to say that the next sensor is actually a really interesting sensor, and it is a near infrared sensor. So to my knowledge, this near infrared sensor is only used on 2 phones, which is the Honor Magic 4 Ultimate and the Huawei P50 Pocket. So as the name kind of suggests, what a near infrared sensor does is that it captures the lower portion of the entire infrared spectrum, which is called the near infrared range. And besides phones, what a near infrared sensor does is it detects the composition of materials, so it can be used, I think, in construction purposes and environment conservation purposes, like detecting plastic versus wood and stuff like that. And it can also be used in medical purposes, such as detecting blood flow and doing stuff like that, kind of like an X-ray. So the way the P50 Pocket and the Honor phone use that near infrared sensor is actually probably in two different ways, but let's start with the Honor first. So I don't have a complete answer for any of them, but my guess is that it's using the near infrared spectrum to take in the composition of materials and put that into the photo processing. So let's say you're at the beach and you're with the Honor phone taking a photo. Well, with that near infrared spectrum sensor, it can basically detect the sand, detect the water, detect just natural air, and detect you and differentiate all of that and put it all together so that it can process every material basically differently. And this is also a guess, but this makes complete sense because you're basically at the beach and the sensor can recognize that, oh, this is you, the sand's right here, the background's right here, right? Because it can detect the composition of different materials, it's basically working like a depth sensor as well. So for like portrait bokeh cutouts, because it knows that you is you and everything else is just everything else. So that's actually really cool if that is true. Now for the Huawei P50 Pocket, I'm guessing it does the same thing of detecting the composition of materials and putting that into photo processing and doing the whole depth sensing thing. But for sure, there are two additional features the P50 Pocket can do. The first is the P50 Pocket's fluorescence mode, which basically also has a UV light emitter, and it basically shoots that out and it uses that near infrared spectrum in conjunction with the main camera sensor and stitches them together. So it's like a UV light kind of camera. And the next one is actually kind of cool as well. So there's something called sunscreen mode on the P50 Pocket, where it basically shows you where you have applied your sunscreen correctly. And the way it works is basically because it can detect the composition of your skin versus the sunscreen, it can show you which spots on your face are missing sunscreen. So that near infrared sensor is really cool because it can detect you versus your surroundings and put that information to photo processing and stuff like that. But other than that, I don't know. Like, it's cool, but I wish I had more information on it. The last sensor is really fast. It's really quick. It's called a flicker sensor. Basically what it does is that it detects if the light sources around you or the TV displays around you are running on 50 hertz or 60 hertz or whatever, and use that information to adjust the shutter speed and prevent banding artifacts and stuff like that. It's a really basic sensor. You can see it on the Pixel 3. It's right there next to the camera. And here's a little quick demo of, this flicker you see with laptop displays, and then with that flicker sensor, it just basically corrects it because the shutter speed was corrected. So now that I've explained everything to you, I'm going to explain what sensors are actually good and what sensors are actually really worthless. Well, here's the weird thing. I think they're all good, but it really does matter on how you implement them on your phones. Like 2 megapixel depth sensors are bad. That's a fact, okay? But if you give a 40 megapixel depth sensor, so an actually premium sensor, to someone like Huawei, I'm pretty sure they can figure out, like, okay, we have a 40 megapixel monochrome sensor. We're going to use this for boosting dynamic range, boost low light performance. Like, if you give an actually good monochrome sensor to someone like Huawei or Google or whoever, they're going to use it effectively. It's not going to act so much as filler because the sensor itself is actually like more premium and does have a legitimate purpose. And then we have laser AF, DTOF, and LiDAR, and all of them are really good. But if I had to pick one, it'd have to be DTOF because my Huawei P30 Pro already has it. It's used for depth mapping, for bokeh cutouts, and it's used for AR applications, and it's used for autofocus. And I think it works really well. So out of those three, I just pick DTOF. And I've said it plenty times before, and I'll say it again. When you have real hardware assisting your software, you're giving your phone information that otherwise would have to be calculated by software itself. For example, bokeh cutouts. If you have just a main sensor and that's it, your main sensor has to use all of its software to determine what is the foreground and what is the background. But with DTOF, you have real hardware providing real hardware-based information to the software so that the software can use that depth mapping information and apply an even more realistic bokeh cutout. So I live by that philosophy, and I really wish we had more hardware, for example, time-of-flight sensors on phones, because I really like them. And as for color temperature sensors, well, every phone has them, but it's on the front side of the phone. And when you move it to the back side of the phone, that's when I have a really big problem. That's when that color temperature sensor acts more as a filler sensor than it does act as a legitimate sensor. At the same time, it does make more sense to put the color temperature sensor on the back of the phone rather than the front of the phone so that I can assist, those other sensors on the camera bump. But when you don't label it or you don't have good documentation of, oh, what is this extra sensor on my phone? Because I have an ultrawide, a telephoto, and a main sensor. What is this fourth sensor? Because the documentation doesn't say what that fourth sensor is. Like, as long as you can explain that, yeah, that's a color temperature sensor on your back of the phone. And yeah, it looks like you have a quad camera setup because it's stylish and symmetrical and stuff like that. But if you don't say it's a color temperature sensor, specifically listing it on the product page, then I do have a really big problem with that. And that's what Huawei basically did. And kind of Vivo, but Vivo's worse than Huawei. Vivo basically didn't label it at all, and all of that had to be my interpretation of it. And then we have this fairly novel sensor, this near infrared sensor, which I think is really cool for it to detect materials and distinguish it, from each other, so it knows what you are because you're made differently than, for example, like my desk or whatever a building is made of, like bricks, stone, concrete, whatever, right? But at the same time, I don't have much information on near infrared sensors. So while I would like to kind of hype it up in some way, I still have a lot of unanswered questions. But from my assumptions and kind of theories about it, it does look pretty cool. But at the same time, we'll literally have to wait and see if it's actually the future or if it's just a one-time thing for Huawei and Honor phones. And then lastly, we have a flicker sensor, which I really don't know how I feel about it. Like, can't software automatically determine, hey, this is 50 hertz, hey, this is 60 hertz, hey, this is 90 hertz? Like, do we really need a flicker sensor on a phone? Like, I'm okay if a flicker sensor is on my phone, as long as it's not part of the camera bump where it's like misleading, like a color temperature sensor, then I'm kind of okay with it. But at the same time, the flicker sensor is really small, so it would be really hard for Huawei or anyone else to really kind of make it seem like a quad camera setup, since that flicker sensor can literally fade in the background. So I really don't know. Like, flicker sensors, good, but I just wonder if software can legitimately replace it. I guess my final thoughts on this is that out of all of the sensors, DTOF, direct time of flight, is my favorite. I love it on my Huawei P30 Pro, and I wish more phones have it. I wish my next phone has it. I wish, I don't know, a Google Pixel device has it. Asus phones has it. Every phone has it. I wish more phones had DTOF because it has a lot of benefits. And on that note, please, manufacturers, explain all of this to us. Explain what flicker sensors are, what color temperature sensors are, what time of flight sensors are. Explain all of this information to your consumers. Otherwise, I'd have to make a video just like this, explaining it all. If you like this video, then please give me a like. And if you didn't like what you see, well, you know what? I hope your next phone has a bunch of filler cameras and it looks like an abomination. But if you did like what you see, please like, comment, and subscribe. And yeah, keeping you informed on these topics should be awesome. And also just check out my other video. The precursor to this video kind of explains more about the software processing, a little bit hardware too, but it's just as good as this video explaining all the camera tech, software, hardware, it's all good. So yeah, thanks for watching. My next video, if I plan it correctly, should be really interesting and be related to, of course, cameras, but I don't know. It's nice coming back with a video essay, and my next video, if I plan it correctly, should be really different to everything I've done so far. So hopefully that comes out well, and hopefully you enjoy that. But even so, thank you for watching, and I'll see you in my next video. Bye bye.